If we were looking at a segment and we wanted to find its midpoint, we could use the midpoint formula. The midpoint formula will give us a point, so in x and y coordinates, where the x value is the average of the x values from the endpoints, so it'd be x1 plus x2 over 2, and the average of the y values from the coordinates for the endpoints. That would be y1 plus y2 over 2. This is our midpoint formula. So anytime we have a segment on a graph, we can use this formula to help us find the midpoint. So we already have a segment on our graph. We have segment AB. If we wanted to find the midpoint, we could even label our points x1, y1, x2, y2, and plug them into our formula. So our midpoint will be the average of the x's, so that's 2 plus 8 divided by 2, and our y values, 4 plus 2 divided by 2, which we simplify and we get 10 over 2 and 6 over 2, which gives us our midpoint is the coordinate 5, 3. Now let's go and find that on our graph. That would be right here. We're going to label that M, and it is 5, 3. We could even go, since now we know that the midpoint, we know that AM is congruent to MB, because by the definition of the midpoint, it's a point that breaks it into two congruent segments. Let's look at another one. Now we have points C and D. Again, we're going to use our midpoint formula, which gives us the coordinates for the midpoint are equal to x1 plus x2 over 2, y1 plus y2 over 2. Plug in the values we have for C and D. We get that 4 plus 6 over 2, and then 3 plus negative 1 over 2. We simplify and we get 10 over 2 and 2 over 2. So our coordinates for our midpoint are 5 and positive 1. If we go and graph that point, it would be actually on the line. We'll call that M, and our midpoint again breaks the segment into two congruent parts. CM is congruent to DM.